Hello and welcome to all my dear students. Today we will begin with a new chapter called Metallurgy. Metallurgy is the science that deals with the extraction of metals from its ores. 4.5 billions of years ago, from the time Earth is formed, there is various reactions that is taking place every day. Every day, the main source of energy for this reaction is, we all know, the sun's energy. So, there is formation of ores, there are formation of different types of liquids, there are formation of different types of gases which can be used to extract metals. Okay? And metallurgy is the study of this extraction of metals, study of properties of metals, etc. Now, to understand metals, first we should know that substances. We all know that substances are classified into two types, which are elements and compound. Okay. So, substances of two types, which are elements, first type, and the other compounds. Compounds we will discuss later. Elements are again classified into three: metals, non-metals, and metalloids. And in today's class, we will discuss in detail about the properties of metals and non-metals. Okay, so let's get started. Take your pen, book, and write the difference between metals and non-metals along with me. So as I said, metals are hard and solids with the exceptions that I explained. Similarly, non-metals are generally soft, but there is an exception. There is a hard non-metal which is called as diamond, which is the hardest known substance. Hardest substance. It is the hardest substance, but it is not a metal, it is a non-metal. So this is the exception for non-metal. Okay. Then I told you non-metals come in solid form. Example, carbon. Okay. One example we'll discuss. Liquid form, the gaseous form, chlorine, oxygen, nitrogen. Okay. Cl2, chlorine, oxygen, nitrogen. All these are the non-metals in gaseous form. The non-metal in liquid form is bromine. Bromine, by heart it. Which is the non-metal in liquid form? Only bromine. Only bromine is a non-metal in liquid form. Remaining the somewhat carbon, phosphorus and all are non-metals in solid form. The non-metals in gaseous form are chlorine, oxygen, nitrogen and all. Okay. So these examples you keep in mind. Understanding non-metals in solid form, carbon, phosphorus, etc. Liquid form is only bromine. Only bromine is a non-metal in liquid form. Then for gaseous form, chlorine, oxygen, nitrogen. Okay. Now let us go for the next point. So till now what we have discussed is metals have 1, 2 or 3 electrons in the valence shell. So if I say this point, one element which was a big headache in the periodic table, which was very confusing element, and that is hydrogen. Now hydrogen has one electron in the outermost shell. Where will hydrogen go? Hydrogen, we know that it is a non-metal. So here I have to write except hydrogen, which is a non-metal. Except hydrogen, which is a non-metal. Hydrogen is a non-metal. Okay. So that is an exception. So for every point you have exceptions. And non-metals, you have 4, 5, 6 or 7 electrons in the valence shell. That is the deciding criteria for non-metals. Then I said block number S, group number 1 and 2, they are metals. Whereas P block elements are non-metals. Periodic table is majority filled with metals. Lanthanide, actinide, all those are metals. Okay. The second point that we discussed was metals are hard with some exceptions like mercury, which is in liquid form. Gallium, lithium, potassium and sodium are soft metals which can be cut with knife. Okay. Then they are solids. Metals are solids with some exception mercury. Mercury is in liquid form. Okay. So this you have to remember. Now, what about non-metal? Non-metals are in solid, liquid and gaseous form. Examples I gave you: for solid, carbon, phosphorus. Liquid, only bromine is a non-metal in liquid form. Gaseous form, chlorine, oxygen, nitrogen. Then, talking about softness, non-metals are generally soft because most of them are gas. No, most of them are gas. They are soft except diamond, which is the hardest known substance. Diamond is the hardest known substance. So that is an exception for non-metal. Now let us discuss the further point of distinction. Next point of distinction between metals and non-metals is metals have very high melting point and boiling point. Okay, high boiling point and melting point. Again, there is an exception which I am very sure you will get it very soon. Melting point means solid should melt. That melting point. Now there is a metal which is in liquid form. So that metal will have a low melting point. That is, what is it? Mercury. Except mercury. Okay, except mercury. So mercury is an exception. Whereas if you go for non-metals, opposite. They have low melting point and boiling point. They have very low melting point and boiling point, except carbon you can consider, but no need to write that. Carbon is an exception for non-metal. Now here a very important metal which has highest melting point is tungsten. Okay, tungsten has the highest melting point and that is 3422 degrees Celsius approximately. This is the melting point of tungsten. Okay, so that point is clear. Now we go on to the fourth point of distinguish between metals and non-metals. Metals have a shiny texture. Shiny texture means, in one word you can call it as lustrous. Lustrous means they shine. Okay, they shine. Metals have a shiny texture. Again, there are exceptions, whereas non-metals have, they don't shine. They have a dull texture. They have a dull texture. And here the exception is, which is the exception? The form of carbon, that is diamond, except diamond. We all know how shiny a diamond is. Okay, it shines brightly. So this is an exception for non-metal. They are generally dull in texture except diamond. Now again, for metals, shiny texture I said, in that there is an exception which is lead. Lead don't shine. Okay, except lead dull texture. Okay, this is an exception. Right, mention it. Exception. So lead is a metal but the texture is little dull. Next point of distinguish is most important. In your lower class you have studied about it. Metals are ductile. Metals are ductile. Ductile means they can be drawn or converted into thin wires. They can be converted or they can be drawn into thin wires. Best example are the silver, gold ornaments that we wear. 1 gram gold and all you have purchased, no? 1 gram, nice earrings you get. Okay, nose rings you get for 1 gram and also 1 gram gold can be converted into thin wire. This property of converting metals into thin wires is called as ductility. So metals are ductile, whereas non-metals don't have this property. They are non-ductile. They don't have this property called as ductility. They are non-ductile. Most of the non-metals are, most of them, again use your common sense, they are mostly gases. How can they be drawn into thin wires? Not possible. Okay. So metals are ductile, drawn into thin wires. Example, gold, silver, copper wires we are very much aware about. Okay, these are the examples. The sixth point of distinguish between metals and non-metals is about malleability. Along with ductility, we have always discussed malleability. Malleability means they can be beaten into sheets. Beaten into sheets. They can be beaten into sheets. Malleability means metals have a capability to be drawn into sheets. You can convert it into sheets. Same way, non-metals don't have the property of malleability. They lack malleability. They lack malleability. Lack of malleability. Okay, when I talk about ductility and malleability, again there is one more point wherein we can distinguish between these two, and that is about their brittleness. The brittleness property. Brittle means something which you can break. They are brittle. Now these metals, you can't break it. You can convert it into thin wires or you can beat it into sheets, but you can't break them. So can I call metals as brittle? No, they are non-brittle. They are non-brittle. Okay, except zinc. So there is an exception here, except zinc. Zinc, if you put force on zinc, it may break. Okay, it may break. Use your common sense. Connect it. Metals can be drawn into thin wires and it can be beaten into sheets. But you can't break them. So metals are non-brittle. Except zinc. Okay. Zinc we can't beat them into sheets because they breaks. So this is an exception. Zinc is brittle. If you go to non-metals, non-metals are brittle. They are brittle. Okay, they are brittle. They can be easily broken. One more point we can distinguish between metals and non-metals is related to density. As we know, the bond in metals is very strong. So most of the metals have high density, whereas most of the non-metals have low density. Again, an exception here is diamond. Diamond has more density, has a high density. Okay, most of the metals have high density. Here exception is again the metals which can be cut with knife. Sodium and potassium is an exception. Here non-metals have low density and except diamond. Okay, except diamond. Then the next point, most important point of distinguish is metals are good conductors of heat. Good conductors of heat and electricity. Whereas non-metals are bad conductors of heat and electricity, which is an exception for bad conductor of heat and electricity for non-metals. An exception is the forms of carbon. Two forms we will discuss. One is graphite and the other is diamond. Okay. Diamond is a bad conductor of electricity, whereas graphite is a good conductor of electricity. Good conductor of electricity and diamond is a bad conductor of electricity, and both are coming under non-metals. Okay. Graphite conducts electricity, so it is a form of carbon. Carbon is a non-metal. Graphite and diamond both are forms of carbon, but graphite is a good conductor of electricity and diamond is a bad conductor of electricity. So that is an exception regarding conduction of heat and electricity. Okay. So till now what all points have we discussed? You can write in any order. We had discussed about solid. Metals are generally solid except mercury. Then metals are hard except sodium, potassium, gallium, lithium. Okay. Non-metals the opposite. Again there was exception. Metals have luster. Non-metals are dull except, this point I think so I did not mention, non-metals are dull except there are again exceptions there. Iodine, shiny crystals. Okay. Iodine shines. Diamond shines. All these are having luster, which are exceptions when you are talking about luster. Again, there is a property which is only with metals, that is, metals when they strike with each other, they produce sound. Okay, they are sonorous. They possess a property called as sonority. They produce a sound when they are strike with each other. When they are made to struck with each other, they create sound. So that is called as sonority, or we can call that metals are sonorous. Metals have high density, non-metals density is low. Then we discussed about melting point and boiling point. Metals high melting point and boiling point with some exception. Sodium, potassium, mercury and all are exception. Non-metals have low melting point and boiling point, and I had discussed with the exceptions. Okay. So go through the properties, write and learn side by side with the exceptions that I told you. So in today's class, we had discussed about the physical properties of metals and non-metals in terms of number of electrons present, in terms of luster, in terms of melting point, in terms of density, in terms of hardness or softness, in terms of good conductors of heat and electricity, bad conductors of heat and electricity. These are the things that we covered, whether they are brittle or not. Non-metals are brittle except diamond, whereas metals are non-brittle, okay, except zinc. Ductility, malleability, all these things you have to keep in your mind. In the next class, we will be discussing about chemical properties of metals with some chemical reactions. So till then, stay tuned with this chapter. Complete whatever I tell you, complete in your book, and please share it with your friends, those who are in need, and support my channel Progress with Raji Miss. Thank you, my dear students. See you in the next class. Bye.